Welcome everyone. Welcome to the Java sessions. So in today's session, we'll be going to see a very important topic in the object-oriented concepts. Okay, that is nothing but your inheritance in Java. Okay, as soon as you heard about inheritance, few things will come into mind, like inheritance, like something we are fetching from other objects. Okay, something we are fetching from other objects. Okay, yes, that's true. Okay, let's see more about today's topic sessions. Okay, in today's session we'll be discussing about inheritance and polymorphism as well. Okay, so in inheritance we'll be deeply discussing about what is inheritance. Okay, why use inheritance in Java, terms used in inheritance. Okay, that is terminologies, implementation of inheritance, types of inheritance in Java. Okay, and we'll be seeing about the polymorphism. Okay, types of polymorphism, static polymorphism and dynamic polymorphism. Inside that, that is nothing but your method overloading and method overriding. And later on, we'll be seeing about the implementation. Like we'll see all at once about the implementation. Okay, now let's start with inheritance. So as I told you, inheritance is a mechanism or a process, okay, that is used to get the properties or attributes from from another class or from parent class. Okay, for example, if you take up a parent and child relationship, relationship. Okay, now there we have a father and son. Okay, let us take a father and son here. So what currently assume that father is working and he is taking care of his family. Okay, and son, he is learning. Okay, still he is in the stages of learning. So in order to take care of son learning, okay, what son has to do, he has to get some properties, like some support from his father, right? Some support from his father. Okay, now this, what is the relationship between them to support? That is nothing but parent and child relationship. Okay, in the same way, in the programming also we have parent and child relationship between two classes. Okay, between two classes. Suppose when you want to connect one class with other class, or suppose when you want to get attributes or functionalities or a behavior or methods from one class to other class. Okay, so we have used object creation, right? We have used object creation, but in the case of classes, okay, in the cases of class to class, okay, now from here onwards we are going to use the inheritance. Okay, we are going to use the inheritance concept so that you can create a object for existing class itself. Okay, or I can say, suppose if you want to utilize the already existing functionalities in some class, okay, and you want to implement it in the another class, you just want to use it by calling it, okay, by method calling or function calling, whatever it is. Okay, you need to utilize it. Okay, at that time this inheritance concept comes. Okay, so inheritance can be defined as a process where one class inherits the properties, that is your methods, fields, that is nothing but your attributes of another class. With the help of inheritance, we can make the information manageable in hierarchical order. Okay, we can maintain the information or maintain our data, okay, in a better way. Okay, the idea behind this inheritance in Java, okay, that is you can create a new class, okay, that are built upon existing classes. Okay, by taking a existing class or a functionalities as an example, you're trying to build a new class and providing a new implementation using those existing implementations. When you inherit from one existing class, you can reuse the methods, fields of a parent class. Okay. Moreover, you can add new methods and fields in your current class also. And when it comes to your aggregation and association and composition, here your inheritance is using a relationship, okay, which is known as parent-child relationship. Your inheritance is using is a relationship, okay, like however your aggregation and has uses the has a relationship there, okay, where one class is depending upon the other class, okay, dependent and independent, okay, aggregation and composition there, okay. Now, why we use inheritance in Java? Okay, the most important use of inheritance in Java code is reusability. Okay, because as I told you, if you want to fetch the data from one class to another class which is already existing, at that time, this functionality this will help us to avoid the creating a new functionalities and new attributes. Okay, we can make use of existing only. Okay, and also method overriding, also known as runtime polymorphism. Okay, here we can achieve polymorphism in Java with the help of inheritance also. Like there is a concept called polymorphism. We will also discuss that in the later stages after this inheritance. Okay, now we got to know why we use inheritance. Next, terms used in the, that is terminologies used in the inheritance. First, class. A class is a group of objects which have common properties. Okay, it is a template or a blueprint from which objects are created. Okay, and subclass and child class. Subclass is a class which inherits from other classes. Okay, for example, in your parent and father and son, okay, you can call son is a subclass or a child class, and it is also called as derived classes or a extended classes. We have multiple names here. You need to keep this terminologies in your mind. Okay. Next, we have a super class or a parent class. Here you can call your father as a parent class. Okay. A super class is a class from where subclass inherits the features. It is also called as base class, parent class, super class. Reusability. As the name specifies, reusability is a mechanism which facilitates you to reuse the fields and methods of the existing classes when you create a new class. Okay. Now we have types of inheritance. Okay. In types of inheritance, we have single level inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, hybrid inheritance. Okay. Now what we can do, let's go ahead for single level inheritance. Single level inheritance. Okay. Now, in a single level inheritance, let us go back to my Eclipse. This is my Eclipse. Okay. And how to create a project in the Eclipse here? Go to File, New, Java project. Okay. And define like a concept. Okay. Inheritance demo. and you can click on finish. I don't need a model here. Okay, let me create a new package as well here so that I can maintain these things. Okay, I'll provide my package name and click on finish. Now I will create one class. Okay, and I will name that class as a animal. I'll name that class as animal. Okay, now I have named that class as a animal here and click on finish. And you can see I don't have any main method or any other methods. Okay, what I do, I'll just create a static method here. Static, okay, void animal. You can see there is a case is different from this class and method name. Okay, and see here, I'll just print one statement called system dot out dot print ln. Okay, fine. So inside this, I'll say, if I say animal, there are different types of animals, right? Different types of animals like your dog, cat, monkey. Okay, so I'll say there are different types of animals. Okay, like dog, cat, monkey. Okay, so I'll just enter this. Yeah, so that I can, yeah, I can use this. And here also space is more. Let me adjust my Eclipse. Okay, now it is adjustable. Now you can see I have created a class called animal and I have declared there one simple method, static method, void animal. Okay, inside that I just printed some statement. Now, if I say animal, okay, I need to list out all the animals as well. Okay, what I do, I'll just create a class called, okay, dog. Okay, you can see I just created a class called dog and say static void sound. Okay, what is the sound of dog? System dot out dot print ln. Dog barks, right? What sound dog makes? It barks. Okay, fine. Now you created this. Now I'll just go here and I'll create a one more class. Okay, and I'll just say single level inheritance. Single, okay, single level inheritance with a main method. You can see I created a single level inheritance class with a main method. Okay, now what I do, I'll just create an object of the dog in a single level inheritance. Okay, dog, okay, db new dog. Okay, now db dot, okay, I'll call the sound. Okay, let me run this now. You can see dog barks. Okay. But I want to know what is the dog here? What do you mean by dog here? Whether it is an animal, whether it is a bird, whether it is a human being, whatever it is, or whether it is a reptile. Okay. I want to know. Okay. So as I specify here, dog comes under animal. Okay. Now definitely dog needs to get the properties from animal, right? Dog needs to get the dog class needs to get the property from animal, right? How can it get the property from animal? Okay, it can get the properties from the animal by inheritance concept using a keyword called extends. Okay, extends and the class name where you want to get the property. You can see here dog extends animal means with the help of this extends keywords you are able to get the all the attributes and methods present in your animal class. Instead of creating an object of the class, you are directly passing it to class itself, so that you can, whenever you create an object for the dog class, you can directly access features of animal as well. Okay, for now I'll just comment this extension, and you can see here when I specify db dot, okay, you can see, is there an animal there? Is animal method I cannot, can I access it? No, because animal method is present in the animal class, but you are trying to create an object for dog class and trying to access it from dog here, which is impossible as of now. Now for this, what I do, I'll just use the extends keyword and call the animal class and go back here and save it. You can see you're able to see these features. Now let me run this. You can see dog barks. There are different types of animals like dog, cat, and monkey. Now what happened? You were able to access your dog animal class via dog using extends keyword. Here your dog is sub subclass and your and animal is superclass. This is a superclass. Okay, or base class. Okay, or parent class. Okay, and your dog where you are getting the properties. This is a subclass or child class or derived class or extended class. Okay, subclass, child class, derived class, extended class. Okay, and the type of inheritance you are performing here, it is nothing but a single level inheritance. What is a single level inheritance? In a single inheritance, a single subclass extends from a single superclass, extends from one and only single superclass. Okay, you can see, is your dog extending properties from one and only its superclass? That is from animal. Okay, Fine. Now we have a multi-level inheritance. In multi-level inheritance, a subclass extends from a superclass and then same subclass acts as a superclass for another class. Means here you can see the class A is extending properties from, you can see class C is extending properties from class B. In turn, your class B is extending properties from class A. For example, you can assume grandfather, father, and son. Grandfather, father, and son. Okay. Like you are getting the properties from your father, and your father is getting got the properties from his father, that is grandfather. Okay. This is a multi-level inheritance. More than one superclass. It's like a chain. Okay. It is like a chain. Links one after the other. Okay. Now, for an example, what I can do, I'll just create one more package here, demo 2. Okay. Click on finish. Let me close all these things. And in demo 2, I'll just create a class called grandfather. Class called son, I will create. Okay. Click on finish. So in this class, what I do, static void, okay, child, fine, and say here system dot out dot print ln. Okay. Okay. What I do, I am okay. This is child class inheriting inheriting properties from father class. Okay. Now I'll create a other class. Okay. Click on finish. Okay. And say here static. Okay. Void and say the method name dad. Okay. So same statement I need. This is father class. Inheriting properties from grandfather. Okay. Now what I do, I'll create a class called grandfather. Okay. And here a method static. You can create your generic methods as well, non-static methods as well. No issues. Okay. Grand parents. Okay. Mm, he needs to be specified that. Okay. Okay. You can see here. Now your grandfather is there where he is getting properties from his grandparents. Okay. Now property, how it is going from one person to other person? Multi-level, right? First, you are trying to get properties from your father class. Okay. Say extends father. Now, if I try to create a class, okay, that is multi-level, okay, with a main method. Now, create a object for the son class. Son is equal to new. Okay, it is a smaller case, okay, smaller case here, and s dot father. Okay, s dot, sorry, dad. You can see you're able to access the dad here. There is something else. This static method from the father access in a static way. Where is my multi-level? Okay, now it is resolved, like just shown somewhere. You can see the father class inheriting. I call the dad here. Okay. So for that, it is calling, this is a father class inheriting properties from grandfather. What I do here, again, I'll say s dot. Okay. So what is the method I have mentioned here? Child, child in the son. Okay. Now you can see this is a child class inheriting properties from father class. And here in the father class is inheriting properties from grandfather. Okay. Now same way, you can see your grandfather here, and in the grandparents, in grandfather it is inheriting from grandparents. What I do, okay, I will extend the properties from grandfather. Now you can see, now I'm completely able to access all three methods being a son here. Okay, all three parents properties. Okay, you can see here, this is grandfather class inheriting properties from grandparents. Okay, here, unless or until your father access, you can't access your grandparents properties there. Okay, that is the scenario. Okay, so this is about the multi-level. Next, hierarchical inheritance. Okay, for example, hierarchical inheritance. Okay, suppose there is a situation where you can, okay, where you want to access the properties like as a second son 2 here, I'll say son 2. Okay, okay. Now, as a son too, okay, I can access directly properties from my grandfather. Okay, I can access directly from my grandfather. What I can do, I'll just extend cx and extends, okay, from grandfather. You can see your grandfather is providing properties for, okay, father, okay, father as well as son too. For both of them, it is directly providing the properties. But for the son, you can able to access properties of his father only. But here son 2 is getting properties from your grandfather and father as well. Okay, So you can see the scenario here. You can see class A, class B, and class C. Assume that father and son too. Class B is your father, and class C is your son too. Okay. For both of them, who is providing the properties? Grandfather. That is class A. Okay. That is a scenario here. Okay. Now, if I say here, uh, public void son 2. Yeah, now child 2 I say here because the name already exists there. It creates an issue. Okay. Now system dot out dot print ln. Okay. Grandfather class. Okay. Now if I try to run this in a separate class here. Okay. With a main method. Now what I do, I'll just create sun2 here. A sun2 object here. Yeah. I will say s dot child2. You can see able to access the properties. This is a child class, a child2 class, inheriting properties from grandfather. Getting it? So you're able to access class A and class A to the class B as well as class C. Okay. So next is a multiple inheritance. Okay. Next is multiple inheritance. Okay. So multiple inheritance, it's a failure concept here. Like it won't work in using classes. You can't achieve the multiple inheritance using classes. For example, okay, I'll say here create a class called grandchild. Okay, fine, grandchild. Now, as a grandchild, I will create here method. Okay, public void. Okay, child t. Some method like this. Okay, and say example here. Now, as a grandchild, I want to get the properties from father as well as grandparent, grandfather, father as well as grandfather. So what I use extends keywords. I will use extends father. That's fine. Then how can I extend grandfather? How is possible here? How it is possible? It can't be possible. You can see here. I hit the comma here and say grandfather. You can see syntax error. You can syntax error. Okay, you can't achieve multiple inheritance using classes. Okay, so here multiple inheritance when you try to access from two or more classes, or when you try to inherit properties from two or more parent classes. Okay, at that time in the compilation itself, compiler will throw an error. Okay, because this is because the compiler doesn't know which class method to give the priority here. Okay, here comes the priority concept. Like to which class I need to give the priority. Due to that, a diamond problem will be created. Due to that, diamond problem will be created because of the priority. Compiler doesn't know to which method, in which class I need to give the priority. So to avoid this confusion, okay, Java does not support multiple inheritance using classes, but it can be supported using interfaces. Multiple inheritance supported using interfaces that we learn in the later stages of the course. Okay, and your hybrid inheritance also. Here you take your hierarchical inheritance plus your multiple inheritance. Again, the half of the logic will work and half of the logic will doesn't work here. Okay, class A, B, C, which falls under hierarchical inheritance, this will work. But from your class D is accessing properties from class B as well as class C, which doesn't work here. Okay, fine. So this is all about the inheritance concept. Okay, you have seen types of inheritance, how to implement them. Okay, how to use your extends keywords. Okay, next we are going to see about the polymorphism. Okay, polymorphism concept. So what do you mean by polymorphism here? So basically polymorphism, okay, the word itself, okay, says many forms, many forms. So polymorphism means many forms here. Okay, it can be defined as when one thing has many forms. Okay, it is known as polymorphism. Is the ability of entity to take several forms. And your polymorphism is derived from the Greek words that is poly and morphs. Poly and morphs. So poly means many and morph means forms. For example, if you take a person as an example, person, okay. So when he is in home, then he can say like he is a family member. Okay, in a family member, he has some certain position like a son or father or grandfather like that. Okay, so when he goes to office, when the same person goes to office, he will be an employee in the company or a office. He will be an employee in the office or a company. When he goes to some restaurants or markets, okay, then he will be a customer. He will be a customer. And when he goes for tourist places, then he will be a tourist. And when he travels in local trains or any vehicles, he is a passenger. Single person, single person, only one person. Okay, when he goes to different places, okay, he is identified as he is identified separately and uniquely there, related to that place. When he, if person is in home, family member, person is in office, he is an employee, he is in marketplaces or other retail places, customer. If he goes for if he visits some tourist places, he is a tourist. And if he is traveling in any vehicle or something, he is a passenger, right? One person, many forms. Okay, for other example, like what person can do? A person can sit, person can stand, person can walk, person can sleep. Okay, person can dance, person can fight, he can jump. Okay, same person performing different operations. Okay, Okay. Now in Java, okay, we achieve polymorphism through some methods, through the methods. Okay, there are two types of polymorphism. That is static polymorphism and dynamic polymorphism. Static and dynamic polymorphism. Okay, for example, I can give for other examples for your polymorphism. Like water can change its state at various conditions. When it is in solid, it is ice. When it is a liquid, it is a water. And when it is in gas, it's a vapor. And like a human being, as I told you, for the person example, same thing you can take. He can act as a different situation. Okay. Next, static polymorphism. Okay. Static polymorphism, okay, is also known as compile time polymorphism because it happens at compile time itself. Okay. The compile time polymorphism is handled by the compiler. Okay. And the best example for a compiled like static polymorphism or compile time polymorphism, okay, it is nothing but your method overloading. Okay, method overloading can be achieved through static polymorphism. As I told you, polymorphism can be achieved through methods. Okay, here method overloading is an example to achieve the static polymorphism. Okay, so let's see what about method overloading here. Okay, when two or more than two methods of a class have the same name but differ in the signature and differ in the parameter list and differ in the variation in the parameter list, like data type variation in the parameter list. Okay, for example, let me take it out this package demo 3. First I will discuss with one of the thing like change. Okay, method overloading using the changing the number of variation in the argument list. Okay, how can you achieve a method overloading using variation in the argument list? Okay, let me close all these things. Okay, I have created a class called demo. Fine. Now you can see method overloading is achieved by changing the number of arguments. Okay, how can we achieve the method overloading by changing the number of arguments? For example, here I have created a class called sum, and you can see a method is added here, like two methods are added here with the same name. Okay, okay, I will show you here. New class. Okay, sum, right? Sum. I have created a class called sum, and there public. Okay, void add. Okay, int a comma int b. You can see I have added one method, and I will try to create one more method with the same name and variation in the with the same name and same parameter list. Okay, now this complete one statement is called as a method signature. Okay, your method signature contains, Okay, your method signature contains access modifier, return type, okay, return type, method name, and the parameter list. Okay, what are the things it contains? Signature, signature of method, method signature, sorry. Method signature will contain your access modifier, okay, and return type, and method name, and parameter list, parameter. Okay, these are all things it contains. When I say method signature, you need to take it completely. Okay. Now you can see I have created a method with the same signatures, like same method names. Okay, but it is throwing an error. Okay, what I can do, I'll just change here int to double. You can see now this method has changed. Like I am not getting an error. Okay, I will declare one more method. You can see it is throwing error again. So here I will say, you can see, okay, you can achieve method overloading using by creating a same method, like by creating a method with same name, okay, with the help of same name, okay, but variation in the parameter list, parameter list, okay, that is nothing but variation in the sequence of parameter list. Sequence means order, okay, order sequence of parameter list, okay, and data type, variation of data types in parameter list, okay, by changing variation in the order of sequence and variation of data types in the parameter list. Using these things, you can achieve your method overloading. So I'll just say yes, system dot out dot print ln. Okay, here I will say uh, a plus b, okay, and same way, okay, a plus b plus c. We can see here I have created a multiple methods with the same name, but variation in the parameter list as well as sequence. Okay, now sequence also you can see here I will say this as a double. Okay, or I can say in this way also. I will take it out C here. Okay, so here I will say double. You can see it is quite reverse of this one, right? The above method. It is quite reverse of this. This is variation in the data types. Okay. Or one more thing I can say variation in the parameter list. Or variation in number of parameters passed. Number of parameters passed. Okay. So I can say this way. You can see this is variation in the number of parameter list passed. Okay. So this is for this method shows variation in the variation data type variation in the parameter list, and this shows what this shows about number of order sequence in the parameter list, and this is the number of parameters passed. You can see it now clearly. Okay, this is variation data type in the parameter list. Int and int b. You can see int a and double b, and you can see exact this opposite to this method, variation in the sequence, order of occurrence. And this one you can see here, parameter number of parameters passed. Then how can you access them? How can you call them if you have like this? Okay, you can call them in this way. Okay, create an object of the sum class here. Okay, now s dot sum, sorry, add. You can see I'm seeing various methods with different parameters, like same method with the different parameter passed. Like first one is double int double, int, yeah, double int. Okay, so if I select anyone and if I pass the parameters in that way, 2 comma 2, so both are integers. So what it will print? It will print the first one, this one. Okay, now if I say same way, I'll go in this way, 2.9 and comma 2, which is matching 2.9 comma 2, that is a double comma integer, which is matching. This one is getting matched. Okay, this will execute now. 4.9. Okay, now s dot add, and like 8 comma 99.99, that is int comma double, which is matching the second method. Okay, you can see 107.99. Next, the third one, so double integer. Okay, now you can see double integer 30.7. Okay, so in this way you can easily able to achieve your method overloading concept. Okay, method overloading concept. For example, sir, everything is same, but here what I do, I'll change this to my I will add the return type here. Okay, see, in this way I can't achieve my, okay, I can't achieve method overloading for this concept. For this concept, I can't achieve method overloading because the signature is got changed here. The return type got changed. Okay, when you vary the return type also, it doesn't work. Okay, so that's why I asked you, like, to know about the signature. Signature is nothing but which consists of your access modifier, return type, method name, and parameter list. Okay, next is dynamic polymorphism. Dynamic polymorphism is nothing but run in the runtime polymorphism, which can be handled during the runtime by the JVM, that is Java Virtual Machine. Okay, which is handled virtual machine. Okay, method overriding is used to achieve the dynamic polymorphism. This is method overriding. Previously, we have seen method overloading. Okay, what is method overriding here? It is a method in a subclass with the same signature with the specific implementation to subclass. Okay, if a subclass provides a specific implementation of the method that has been declared by the parent class, then it is known as method overriding. Okay, in order to achieve method overriding, we need to follow the inheritance, and we need to have a relationship between two classes. For example, okay, here I will create one method, okay, public void, okay, overtake me. Yeah, this is one of the method. Okay. It says system dot out print ln and say here, okay, you can overtake my bike the speed of 55, yeah, kilometers per hour. Yeah, 55 kilometers per hour. I can overtake his bike by changing my speed to 55 kilometers per hour. Now I will create one more class and say that class name as, okay, super bike. Okay, and have a method here. And you can see now I want to access this method. If I want to access this method, what I can do, I need to inherit the class from, inherit the properties from the sum class. Okay, so extends sum. Now what I do, I need to get this class. I'll get this class as it is. Okay, and in order to overtake this class, I need to specify a keyword called override here. Okay, override. It is a annotation that performs like that specifies this existing method from the parent class, that is from this sum class, is getting overrided here. Okay, I can say here overtake done at 5 kilometers per hour. Okay, now I'll say super bike. I'll create an object of the super bike. Okay, super bike is the equal to new super bike. Okay, and sb dot, okay, you can see overtake my bike. I have only one method. Okay, because, so you can ask me, sir, there is from two methods, right? From the parent class also is there, right? No, it can't be achieved now. Like your parent class method is getting overridden here with the help of override keyword. This is a method overriding. Okay, so you can achieve method overriding in subclasses itself. Okay, if you want to override same method, okay, in the same class, you can't do that. That is not achieved. Overriding a method in the same class is not achieved. Okay, if you want to override that method, you need to use it, override it in the subclass. Okay, with the help of inheritance concept, you can extend that and you need to add it here. Now if I run this, let me see what it will print here. You can see overtake done at 55 kilometers per hour. Okay, now if I didn't overtake, okay, if I didn't do overtake, like override here, okay, now what I say, I'll just comment this code. You can see this code is not executable now because I made a comment there. Okay. Now if I run this method, you can able to see you can overtake my bike at 55 speed. Now what it is printing? It is taking the previous class one, that is parent class. But if you use this method here, what happened? Again, same method with the same signature. Everything should be same, but inside the implementation can be different here. Okay, method overriding is nothing but signature is same, but what, the implementation inside a method is different. Now if I run this, you can see the different overtake is done. Okay, so this is how you can achieve method overriding as well in the subclass by using parent and child, that is using the inheritance concept. Okay, now you can ask me, sir, what is the difference between method overloading and method overriding? Okay, method overloading must have at least two methods with the same name in the same class or also in different inherited classes. Okay, method overriding is must have at least one method with by the same name in both superclass as well as subclass. Okay, your method overloading, when you are trying to create a different methods for method overloading, you need to have variation in the parameter list, variation like different number of parameters. But in the method overriding, it should be same signature, that is same number of parameters. If the number of parameters is the same, then it must have different types of parameters. Like total number of parameters present in the method is same, then it should have different parameters like int. If you have, like, it should have like double int, like that variation in the data type of parameters passed. Okay, but in method overriding, it should be same again, because signature won't change in the case of method overriding there. Method overloading is also known as compile time polymorphism, and overriding is also known as runtime polymorphism. Okay, here method overloading, one method does not hide another, but here one method is hiding another method. That is, your subclass method is hiding your parent class method by overriding it. And static binding is used for method overloading, and here dynamic binding is used for method overriding, sorry. Okay, this is all about your method overloading and riding. Okay, and today's session, like, it was helpful for you guys. Like, we have discussed about inheritance and polymorphism. Okay, these are very important concepts of object oriented programming as well. Okay, so here again the credit goes to these things for the resource. Okay, So thanks everyone. Let's meet in the next session.